Okay, Robert, what's the first item we have here? This is an order from Renaissance Charge LLC, and it arrived today. Thank you very much, Renaissance Charge LLC. And Robert is trained in classical electronics and
Self-taught.
self-taught just from the age of 6, right, Robert?
That's correct.
How did you begin your career at 6 years old? Did you take apart the bed heater? Is that what it was?
Yeah, my parents kind of went to bed one night and it was very cold, so they tried to turn on their electric blanket and it wasn't working. So when they pulled the blankets off, they found out the electric blanket had holes cut in it by me. Because I was curious if I can take the elements out and run them off of batteries and generate heat, because I thought it'd be something interesting to do. And from then on, I was taking apart radios and TVs and just anything electronic that I was curious about.
Okay, great. And here you are many years later running Robert's Computer Hospital.
Yep, fixing computers, installing surveillance cameras, doing any kind of electronic or electrical repair, appliances, electrical, electronic projecting. I do all kinds of anything that has to do with wires and some sort of a power source.
Okay, so people can contact you if they need work done.
Yep.
Robert's Computer Hospital. Okay, so Robert, so tell me what you see here.
Okay, well, let's see. We have this appears to be a Pwm Frequency Meter. That's what it says on here. So basically it measures the pulses of your pulses coming out of a pulse width modulation circuit and counts the frequency and gives you a digital readout of the frequency. And it might also be a generator, but I am unsure. Maybe it just might be the meter. So that's what this is.
Great. Set that here. I'll hand it to me and I'll put it down. Okay, and we have these 2 books too.
Okay, so this is basically a variable capacitor. So you adjust the capacitance by turning this dial right here. These are your 2 terminals.
Wow. A variable capacitor.
Probably another one inside this too. Also, it says variable capacitor.
And Robert, where would you usually find something like that? Would all electronics have something like that?
They do have various versions of this. Larger ones, smaller ones, microscopic ones maybe. Yeah, basically these are found in a lot of places that carry old vintage electronic components.
Okay. When you say vintage, does this look like something that would be used in...
Yeah, you're not going to go find this at Best Buy. They're going to try to sell you a computer that'll last about a month and explode. Then it'll probably end up at my shop in an attempt to be repaired.
And I think you say that because you fixed a lot of computers that people have purchased from there. Is that why you're saying that?
Yeah, Best Buy is actually Worst Buy.
Okay, well, Robert, let's talk about what you see here. What is this? A variable capacitor. Okay.
So basically, you can change the capacitance or basically change the amount of time it stores the current and releases it.
Okay. So someone's asking if the box was yeah, everything was sold separately. It's just I think I ordered almost everything
of interest.
Yeah, I don't remember how I determined what to buy exactly, but I did call and ask for I just wanted to buy all the electronic parts. I didn't buy everything they sell, but I bought everything I could find educational, at least for this stage of my learning process, which is I consider myself a beginner.
Okay.
So Robert, are we off to a good start?
Well, I guess we'll find out when we see what you actually end up doing with it.
Okay. So,
all right.
Yes, so let's go ahead and just look at one thing at a time.
So this is basically a crystal radio kit. So it consists of a variable capacitor. So that's to change your stations by changing the capacitance. And you will find a germanium diode in here somewhere.
How do you know that?
because it's that glass color. It's got little two
Oh.
black bands on it, and that's probably a 1N60, which is a germanium diode.
Okay, well, Robert knows that because you've been doing this since you were 6.
That's right. I know pretty much all the parts in the book. And you might find some coils and probably a crystal earphone in here somewhere.
I think I read that on the list, the parts list.
Okay.
Okay, next.
Next in the box, let's see, we have this circuit here. Let's see, let's get some light on the subject. Sorry about bumping and causing this video to go a little crazy, but we need a little bit of light so we can see what the number on this integrated circuit is.
These books came as well. These books were in there as well, in the box.
Because this chip comes with 3 capacitors on this circuit board. So let's see if we can figure out that number this chip is.
Oh,
God,
let's
my
see.
eyes are
Here,
so
let me see if
bad.
I can zoom in.
Oh,
zoom
there you go.
You actually taught me about the
Now
zoom.
you're talking.
You taught me about the zoom on the phone, how you can get basically
So this
close.
is a
You can get really close with the zoom.
Ixie's Long Dong Ching Ching. Oh, no, wait, I'm sorry. A GD2316.
Pulse PM, they're saying PMW amp.
Oh, it's a pulse width modulation amp. Okay. When I don't know the part number, if it's something that I haven't seen, I usually Google it, probably like all you guys are probably doing right now.
PMW amp.
Pulse.
Yeah.
Okay.
Yeah.
Pulse width modulation amplifier.
I'm trying to zoom
okay.
out.
That's interesting. I've never seen a pulse width modulator amplifier before, but I guess
Robert,
they do exist.
You're learning something.
I never
I
never required one in any of my electronics. I usually amplify output current with a transistor or something close to that to give me higher current off of a pulse width modulated circuit.
Okay. All right.
But yeah, this is the first time I heard of a pulse width modulation amplifier, but that's pretty interesting.
Well, I should say, Robert, that you are always learning because you're always.
Oh yeah, you always learn because you don't know every single thing in the book. There's going to be something that
Here, Robert,
comes up and will surprise you. Yeah.
Yeah.
That's the one thing I love about electronics is that there's always something new and cool that somebody designed and manufactured and squirted out of China.
Okay, so because this video is also children are watching, we have to keep the language very, very appropriate, okay? And polite. Okay, Robert?
Okay, this looks like some sort of a coil...
Fast, sharp shutoff, he said. Alan said.
Fast, sharp shutoff.
Yeah.
Okay, fast, sharp shutoff.
Is that the last thing you had? Yeah. Is that referring to the last item that you were looking at?
Oh, you mean the integrated circuit?
Possibly. That might have been
I'll have
to
Google it so I can be 100%. But
okay, what do we have here? That looks like it's 3D printed.
Yeah, this is something that's 3D printed. It looks like maybe some sort of a coil mount or something.
And there is some coils in here too.
Yep, there's a bunch of coils, which we'll get to last because there's so many of them. But so I guess we'll get to that later.
Yep, we'll get to that.
So I can actually figure out what you're supposed to do with it.
And these books also came here. We'll look at those as well.
So here
coil
is...
holder. Alan said coil holder.
Coil holder. That's kind of what I was guessing.
Yeah.
Just from the appearance of it.
Okay.
Here's an integrated circuit here. That's in an anti-static bag.
Okay, let me zoom in. Look at the screen, Robert.
Yep, it looks... Oh, it looks like it's an extra chip for that PWM booster amplifier.
Okay.
Okay, so I guess if you burn that one out, you got a spare.
Yeah.
That's why it's also in a socket, so you can remove it for easy access.
Alan said yes. He said yes.
Alrighty.
Robert, slide those like this.
Yeah.
Okay.
Like a
appropriate. Okay. Kids are watching this.
I am, yeah. Okay, so
Robert likes telling jokes a lot, but he has to.
I have Asperger's. Okay, let's see. So this is a board with 2 wired loops. It's got 6 transistors, 6 resistors, and 2 LEDs. So basically, the transistors are hooked up Darlington style, but in triple, to take the signal in and amplify it to very high sensitivity. So this is a frequency or a stray signal sensing unit. And
he's asking a question. Static measurer question?
I guess it could probably pick up static electricity too, but mostly stray voltages.
Okay, that makes sense because we're going to be working with high voltage.
So basically, you have those non-touch voltage sensors that the electricians use to check for voltage coming out of a wire. That this does basically the same thing.
And I think
But this is a double. There's one on the left and one on the right.
And yes.
So you can detect if the higher voltage is closer to one side than the other by watching the LEDs. It'll kind of guide you.
Alan said measuring static polarity. So
okay, well, if one is NPN and the other is PNP, that might be a possibility too.
When you say NPN and PNP, what are you referring to?
The transistors.
And which ones are the transistors?
The black ones right there that are half moon shaped.
Oh, I see. There's 6 of them?
With 3 leads on each one, correct.
Okay.
Because you have the base, the collector, and the emitter. The base is what turns the transistor on. If it's an NPN, then the positive turns a transistor on.
Smart.
If it's PNP, then the negative turns a transistor on. So.
Okay. And Robert, I think it's possible that when we go through the books here.
And thank you for calling me smart. A lot of people tell me I'm the hero, the savior, the genius, and I have Egyptians that like to cuss me out in their language, so I know every word.
Robert, these 2 books here may guide in how to use these as well for the projects of learning. Right. And so I'm going to be hopefully guided by you so I don't electrocute myself and hurt myself. I did hurt myself on my thumb, but that was working on batteries. It's healed very well now. I'm just covering it to keep it out of the sun, really.
Okay, that's good.
Yeah. It healed very well, Robert. You saw it. You saw my thumb. Yeah.
Okay, let's see. So we got this one here, which actually came with the paperwork that I think it looks a lot like that other one that was called a pulse width modulation amplifier, but yep, so here's the exact same thing again. And according to this paperwork, let's see, optional 9-volt input, frequency generator input, output to coil. So I guess basically it's like a coil driver integrated circuit or amplifier.
Okay.
Like your guy mentioned on there. I guess they call it a gate chip. Pretty interesting. I'm going to have to look this chip up to see what the specs are on it, see if I can use it for any projects I do in the future. Because I tend to find things to build and use lesser components that do more more damage to the output. Okay, so that's that. So you have 2 of those apparently.
Okay. So I'm hiding chat right now because I'm trying to focus on what we're doing. But I thank everyone for contributing their positive comments and sharing their enthusiasm for this project. And Robert,
and I'm also based out in Eagle Rock, which is a part of Los Angeles between Glendale and Pasadena. So if anyone's interested in hanging out, just feel free to email me at robertscomputerhospital@yahoo.com, and we can arrange like a meeting or something. I'm looking for apprentices. I'm pretty much a lot of people like the way I explain things. So yeah, if you're interested in learning on stuff on the side, hit me up. And this is basically a terminal block, basic. Looks like 10 individual connections.
Okay.
Oh, wait, there's a metal jumper going across. So basically, yeah, some sort of just a jumper block. So basically 5 wires coming in and 5 wires coming back out, maybe to hook up coils or something and interface it with a wire, probably.
Okay. And Robert's sharing what he believes these things to be based on his experience, but we're both going to learn together how these items can be used as we go through the book step by step, and that won't be tonight, but tonight we're going to try to get through what came in the box.
So we basically have an MR11 LED bulb. So probably to see if we can get free voltage out of the air off of a coil or something.
Okay.
Probably what they gave it to you for.
Okay.
That's just a standard LED MR11 bulb.
What are those
12 volt.
usually used in?
Recess lights, garden lights, any lighting in the house.
Okay.
We have another variable capacitor. That was the first thing we explained in the video. We gave you another one of those.
And Robert, the light, what voltage is that light?
It's 12 volt AC or DC.
Oh, really?
Either. Yeah.
Oh, wow. So what is that? What are the contents of that allow that to do that?
Well, they start off with a bridge rectifier at the input, and then they filter it with a capacitor. Then it goes through a LED driver integrated circuit, which is similar to pulse width modulator set to give it a certain frequency and voltage to drive the LED and properly give it its maximum output
Oh, okay, that makes sense.
with the least amount of heat. But then they put a heatsink inside because the LED will get hot anyway, and they have to dissipate the heat through a heatsink.
Okay, great. Does it run more efficiently on AC or DC, or it doesn't matter? Okay.
Okay, we have a NE2 neon light bulb, which operates at 90 volts to illuminate. We have some diodes, some capacitors, some resistors, and this is a... Let me see the numbers on there. I can't read that. My eyes are getting bad. Oh, wait, there we go. What does it say?
Whoa.
2N.
Hang on.
60.
Set it down, Robert. Set it down. I can hold it more steady if you set it down. Okay. 2N. Is it 65090?
Yeah, that's a pretty long number. Usually it's 4-digit. That could either be a transistor, a silicon controlled rectifier, most likely not a triac. So it's either a transistor or a silicon controlled rectifier.
Okay, can I set it down just to get a really steady shot of that number on there?
If it's a silicon controlled rectifier, we have to Google it to be exact.
So
Oh yeah, there's 2N6. Oh, 2N6509G. So that's not a 0. That's pretty interesting.
and then what's the 1G?
I have a feeling it's going to be a silicon controlled rectifier, considering there's a neon bulb and some diodes in there. So probably some sort of a circuit to experiment with high voltage and
Okay.
figure out what to do with it. I assume this project would be in the book.
Yeah, I think everything's in the book.
Okay.
That's my thoughts. I don't know for certain, but these books are meant to be. They came with everything. They came with
Okay.
all this. Yeah.
Alrighty, so this one has a bunch of LEDs. It has the NE2 bulb in it again. A couple diodes, a bunch of capacitors, some high voltage disc capacitors. That's what these blue ones actually are. Here is a variable resistor, but since it's so tiny and probably a low value, they actually call it a trimmer capacitor. But it's basically a variable capacitor. These are usually typically used for changing the frequency and stuff on radio frequency projects and stuff.
Does that have an adjustment inside or no?
That's why you see that little screw head in
yeah.
there. You turn that with the screwdriver.
Oh, okay. And Robert, how do you know the NE2? Is that what it's called, the NE2? How do you know
Because it's a very common neon bulb. They were originally used in night lights back in the 70s.
Okay, but they do come in different voltages, don't they? Some of them?
Well, you have the neon bulbs in the movie theaters that are as long as who knows what, and they operate on thousands of volts.
Oh, so they do make different voltages ones. But you're
If
saying
it's the larger bulb.
the larger one, that size is usually 90 volts. Is that what you're saying?
Yeah, it's a neon gas, which is the same as the gas in the theater neon signs, but
Okay.
you know, obviously they're long, so they take a higher voltage to fire it. This is very tiny, so 90 volts.
And Robert, are they starting to use LEDs in place of neon now sometimes?
Yep. Oh, drastically. Pilot lamps in appliances, basically.
Okay. All right, so what else we have?
And it comes with a electrolytic capacitor. Let's see, the value is 100 microfarad at 450 volts. So basically high voltage storage.
And what's an electrolytic capacitor versus a non-electrolytic capacitor? What's the different kind? Is there many different kinds?
Yes, there is. Electrolytic capacitors typically are polarized unless you get a non-polarized capacitor, which would be used like in a crossover for speaker system to deliver proper frequencies to mid-ranges and tweeters,
Okay.
or to filter out the highs from the woofer by going in parallel across the woofer. They do that also, but typically they are polarized. This is the negative side with the arrows on it and the negative marking. And this is in the bag right now, but the positive lead is usually longer than the negative lead.
Okay.
So positive's over here and negative stops over here. So
I
yes.
see. Okay, great. All right.
Electrolytic capacitors also have higher storage capacity per size.
Yeah.
They do take a little bit longer to charge and discharge because, well, you know, higher capacity and also the consistency of the materials used inside. Disc capacitors are higher voltage for the size. You can put a higher voltage on a smaller size, but then your capacity is so limited, you have a very small capacity.
Okay. Got it.
And they're non-polarized.
And non-polarized means it doesn't matter which way you connect it?
Doesn't matter which is positive or negative because it'll automatically discharge in reverse polarity as you charge it with the opposite. Where an electrolytic capacitor could explode if it's polarized.
Oh, so non-polarized? No, because this is new to me. So, I mean, I'm still understanding this. Non-polarized, are you saying that means that if you can put positive to negative and negative to positive, the input,
Like an AC signal, it'll take it.
and then the output from that will always be the same, or?
Well, it depends on the where the phase stopped when you reverse and when you remove the current.
Okay. I'll learn about that over time.
Okay.
All right, Robert. You probably knew that when you were 6, right?
I don't know. This is a bunch of rubber feet for a case.
Okay.
Looks like. And there's some screw terminals and screws to go with the terminal.
Okay.
Probably spares for who knows.
It'll all make sense when we start putting it together and doing the exercises, I think.
Okay, this is interesting. This is a neon power supply, indoor, type 2. So basically you feed it with, let's see what the voltage requirement is on this. Okay, this works on 12 volt DC.
Oh, nice.
So you can operate off a battery and your voltage will be extremely high at 1,500 volts.
Okay.
RMS. Hey, those are my initials. Funny, right?
Yeah.
So we have... Oh, okay, there's a heat sink with a transistor on it. That's to drive the circuitry inside.
Okay, and let's just show for camera. Let's show what the name is. It's is it called Ventex Technology Neon Power Supply Indoor Type 2? And is there writing on the side of it too, or just, yeah, there's something on the side?
The polarity, the voltage, the power rating. Looks like it takes 12 volt DC at 0.6 amps, which is 600 milliamps. And the output is 1,500 volts RMS. My initials again.
Okay.
Mean square, which is 70% of the, something like that. I gotta kind of read up on that again, brush up. It's been so long. It's 70% of the peak of the voltage or something is what it means.
Okay, Robert. We'll have to have a quiz on that later.
So inside this bag we have a coil. This looks like a iron rod.
Okay.
Which probably came out of an AM coil, but we just have the rod here, so I guess you basically wrap your own coil.
Okay. That sounds right.
Okay. So yeah, we've gone through a lot of stuff here, and probably we just got to roll a wire.
Okay. Roll a wire.
This is probably 20 gauge, probably.
Okay.
Oh, no, wait, this is a single wire. I thought this was a double. Yeah, it's probably still about 20 gauge.
Okay.
Roll of wire. Roll of, looks like 10 gauge wire, I want to say. Yep. Yep, 10 American wire gauge. 10 gauge.
Okay.
4 alligator jumpers. Plastic pipe, PVC type, probably for making a coil or antenna or something of some sort.
Okay.
I see you. All right, let's see here. All right, we have a
Oh, nice.
cutting board, which I guess you can go ahead and glue your stuff on here and do your projects on it.
I like that.
Or you can use it to cut your meat.
Or your vegetables.
Or your vegetables.
Because you don't eat meat, Robert. You're a vegetarian.
I'm a vegetarian since I was 8 years old. Or was it 7?
And you don't eat soy either.
I've stopped, yeah, because that stuff is, I'm hearing bad. So this is basically a spark gap.
Oh, nice.
An adjustable spark gap. So you can adjust the distance. It has carbon tips on it to so it doesn't burn up the metal as the arc goes across.
Carbon tips?
It has carbon, like your pencil carbon.
Wow. So I could use carbon from a pencil as a spark gap?
So just be careful you don't crash them together by,
Yeah, because they'll break. They're brittle.
they'll shatter.
But they can handle high temperature? Is that the idea?
High temperature, high voltage.
Wow. That's really neat.
More coil holders.
Okay. We're getting to the bottom. I see a lot of coils.
Yep, here we go. Now we're down to the nitty gritty of it all, the coils. Oh, they have a capacitor and an LED attached to it already.
Wow, be careful with those.
Well, I kind of got that one a little crooked there.
Okay. Oh, you're straightening it out. Okay.
So
those look so nice.
So we got that one. This one looks like a replica of it, pretty much. Oh, okay. So I guess they're all the same.
Mm-hmm.
So they got you 5 of these.
Okay.
Oh, wait.
What's that?
There's something different.
Something different.
So these 4 are identical.
Okay.
And this 5th one, which is the last one.
What do you see?
I see a dual coil.
Wow. Very nice.
And they look like they both have the exact same amount of turns on them. So for some reason it's for isolation.
Okay.
Either that or you can control half power, full power. Basically there's 3 configurations you can do in wiring these to get different results. You can do series, you can do parallel, or you could, I forgot what the third one was. So you can do series, parallel, or just use one coil at a time. Yeah.
Mm-hmm. And we'll have to also see what the exercises are, if it is exercises. I think everything's going to be explained in these books, but I don't know for certain. I know the books relate to the materials here. There's going to be these books here have information in them. This is all for educational purposes, and I'm learning and teaching myself in the presence of Robert and all the research that I do, what all this can do.
Yep, it'll be interesting.
Well,
light up the town.
That sounds good. Well, thank you, Robert.
Alrighty.
And we'll continue to document our experience of discovering what can be done with the knowledge and wisdom contained in these books here.
And just remember, if you cannot figure it out, it's emotional damage.
What does that mean, Robert?
Oh my gosh.
What do you mean emotional damage? Why does it have to be emotional damage? Who told?
Yeah.
Where'd you get that from?
TikTok.
Oh,
I have a recording on my phone somewhere, but by the time I find it, it'll be midnight.
okay. Robert likes TikTok. Okay, so so thank you everyone, and this is about my journey of learning, and I'm sharing this with Robert because Robert has different knowledge than I have, and maybe we can combine our knowledge to do these experiments, and that I can learn more. That's what I'm hoping, is to learn more. Well, thank you all for watching this video, and this was ordered on Renaissance Charge LLC. You can look at Rick Friedrich YouTube channel, and he also has a website. Thank you very much, and have a great night. Want to say bye, Robert?
Adios. Have fun.
Okay.
Have a good weekend.
Bye, everyone.